Zzzpedia presents Nighttime Knowledge. The Moon. The moon is not what it looks like. It looks bright, but its surface is as dark as an asphalt road. It only appears luminous because sunlight strikes it against the blackness of space. From Earth, it seems serene and unchanging, a calm presence that has been overhead for as long as anyone can remember. But it was born in the most violent event in Earth's history, and it is not staying. Right now, tonight, the moon is drifting away from the Earth at roughly 3.5 centimeters per year. It has been doing this since the day it formed. Almost nothing about the moon is what it seems to be. It looks smooth, but its surface is shattered. It looks cold, but it was once entirely liquid. It looks permanent, but it is slowly leaving. To understand what the moon actually is, you have to go back to how it began. Approximately 4.5 billion years ago, the Earth was young. It had a surface, barely. It had an atmosphere, of sorts. It did not yet have a moon. What it had was a neighbor. A body roughly the size of Mars, moving through the inner solar system on a path that would eventually cross Earth's own. Scientists later named this body Theia, after the Greek Titan who was mother of the moon goddess Selene. The name is the only gentle thing about what happened next. Theia struck the Earth at an oblique angle. The energy of the collision was enormous. Both bodies effectively liquefied. The crust of the Earth melted. Vast quantities of vaporized rock and molten material were thrown into orbit, forming a ring of debris around the shattered planet. Within that ring, beyond the point where Earth's gravity could tear the material apart, the debris began to gather. It clumped. It accreted. In a span of time that was short by geological standards, a new body formed from the wreckage. The moon was not captured from somewhere else. It was not a wandering rock that drifted into Earth's orbit. It was made from the Earth itself, and from Theia, torn free in a collision so violent that both worlds melted. The moon carries pieces of the Earth inside it. The two have been connected since the beginning. The new moon sat far closer to the Earth than it does today, perhaps 1/10 its current distance. From the surface of the young Earth, it would have filled an enormous portion of the sky. Not the modest disk we see now, but a looming sphere, close enough to dominate the horizon. And it was not gray, it was glowing. The entire surface of the moon was covered in a global ocean of magma, hundreds of kilometers deep. The Earth spun fast in those early days. A single day lasted roughly 5 hours. Tides between the two molten worlds were ferocious. Not tides of water, because there was no liquid water yet, but tides of rock and magma, pulled by the gravitational grip between two bodies that had just been one. The moon also had a magnetic field during this period, comparable in strength to Earth's today. It was, for a brief time in geological terms, an active world. Slowly, over tens of millions of years, the magma ocean cooled. As it crystallized, something elegant happened. Lighter minerals floated upward, the way cream rises to the surface of milk. These pale minerals, a rock called an orthosite formed a crust that became the bright highlands visible from Earth today. The heavier minerals sank, forming the mantle beneath. The moon's geography was being determined by density. The light parts rose, the dark parts sank. A world was crystallizing, sorting itself into layers by weight alone. And then, for hundreds of millions of years, the solar system threw everything it had at it. A storm of asteroids and comets swept through the inner solar system. The moon, with no atmosphere to burn up incoming debris and no geological processes to heal the wounds, absorbed every impact. The craters from this period are still there. They have never been filled in, never been smoothed over, never been buried by anything. The largest of them, the South Pole Aitken Basin, stretches 2,500 kilometers across and plunges 12 kilometers deep. It is among the largest impact craters in the entire solar system, and it is still as sharp-edged as the day it was made. After the bombardment slowed, something stirred inside the moon. Volcanic eruptions began to flood the ancient impact basins with dark lava, particularly on the side facing Earth, where the crust was thinner. These eruptions continued off and on for more than 2 billion years. The lava cooled into vast, flat, dark plains. Early astronomers centuries later would look up and see these dark patches and assume they were oceans. They called them maria, the Latin word for seas, the sea of tranquility, the sea of rains, the ocean of storms. They were never seas. They were ancient lava, frozen in place billions of years before any human eye existed to look at them. The last confirmed volcanic activity on the moon ended roughly 1 billion years ago. After that, the interior cooled too much to drive eruptions. The magnetic field had already died, billions of years earlier, as the core crystallized and the internal dynamo went quiet. The moon became what it is today, geologically silent. No plate tectonics, no volcanoes, no wind, no water, no erosion of any kind. The only thing that still touches the surface is the occasional meteorite, grinding the rock into finer and finer dust over billions of years. That dust, called regolith, is not like any soil on Earth. It is glassy, razor-edged, and sharp at the microscopic level, because nothing has ever rounded its edges. On Earth, wind and water smooth every grain of sand over time. On the moon, nothing smooths anything. Ever. The moon became a fossil, a record of the early solar system that the Earth itself had long since erased through its own restless geology. Craters from 4 billion years ago sit on the moon's surface, as clearly as if they were made yesterday. But the moon was not just sitting there. It was pulling on the Earth, and the Earth was pulling back. Since the moment of the moon's formation, the two worlds have been locked in a slow gravitational exchange. The moon's gravity pulls on the Earth, raising tides, not just in the oceans, but in the solid rock of the planet itself. The Earth bulges slightly toward the moon, and the moon tugs on that bulge. This interaction transfers energy. Specifically, it transfers angular momentum from the Earth's rotation to the moon's orbit. The effect is simple and profound. The Earth slows down. The moon moves farther away, When the moon was new, the Earth spun so fast that a day lasted 5 hours. Over 4.5 billion years, the moon's gravitational pull has been dragging on that spin, slowing it, stretching the days longer. To the 24 hours we have today, it is still changing. The days are still getting longer by tiny fractions of a second per century. And the moon is still receding, 3.8 centimeters per year, confirmed to the centimeter by laser reflectors left on the lunar surface during the Apollo missions. A beam of light is fired from Earth, bounces off a small mirror sitting in the dust of the Sea of Tranquility, and returns. The travel time tells us exactly how far away the moon is, and every year it is a little farther. This is not just an orbital curiosity. The moon's gravitational relationship with the Earth shaped the conditions in which life emerged. 4 billion years ago, the moon's pull created tidal zones along the coastlines of a young, mostly oceanic Earth. Water advanced and retreated across warm rock. Organic molecules concentrated in shallow pools, dried, were washed together again, and dried again. Some researchers believe these tidal cycles may have helped drive the chemical reactions that produced the first living cells. The moon may not just be Earth's companion. It may be one of the reasons anything is alive here at all. The moon also steadies the Earth. Without it, Earth's axial tilt, the reason we have seasons, would wobble chaotically under the gravitational influence of Jupiter and the other planets. The tilt would swing between extremes over millions of years, creating climate instability that would make long-term evolution far more difficult. The moon acts as a stabilizer, keeping Earth's tilt within a narrow range. The seasons stay predictable. The climate stays, in geological terms, manageable. The exchange between the two worlds is written into human language. The word month comes from moon. The word Monday means the moon's day. The word moon itself descends from a root in Proto-Indo-European that meant to measure time. The moon did not just appear in human culture. It structured how humans first organized time itself. For most of human history, the moon was not something people could reach. It was something they watched. The earliest evidence of humans paying deliberate attention to the moon may be as old as 30,000 years. Some researchers interpret markings on Paleolithic tally sticks and cave walls as tracking the moon's phases, its 29.5-day cycle of waxing and waning, the most obvious natural clock visible from anywhere on Earth. Whether these early markings truly represent lunar calendars is debated among scholars. What is not debated is that the moon's cycle is visible, reliable, and would have been impossible to ignore. By the time of the Babylonian Empire, the moon was embedded in governance. Court astronomers watched the sky and reported the first sighting of the new crescent moon directly to the Assyrian king. The moment was formal, political, a matter of state. The Greek poet Hesiod, around 800 years before the Common Era, organized an agricultural calendar partly around the moon's phases, telling farmers when to plant and when to harvest, based on what they could see overhead. The moon was a timekeeper, a deity, a calendar, but no one knew what it actually was. For thousands of years, the dominant idea in the Western world was that the moon was a perfect sphere. smooth and unblemished, fundamentally different from the rough, imperfect Earth. This was Aristotle's view, and it held for nearly 2,000 years. In 1609, an Italian named Galileo Galilei pointed a telescope at the moon and saw something that should not have been there. Mountains, craters, shadows. The moon was not a perfect sphere. It was a world with geography, rough and scarred and uneven. Galileo's sketches showed a surface that looked in some ways like Earth. The observation was simple. Its consequences were enormous. If the moon was not perfect, then the heavens were not fundamentally different from the ground beneath your feet. The boundary between earth and sky began to dissolve. A few decades later, in 1651, an Italian Jesuit scholar named Giovanni Battista Riccioli published a naming system for the moon's features. He called the dark plain seas and gave them names that are still used today: the Sea of Tranquility, the Sea of Serenity, the Ocean of Storms. He named craters after philosophers and scientists. The names stuck. 3 centuries later, when the first humans landed on the moon, they landed in a place named by a 17th century Jesuit who thought the dark patches were water. And then, in the middle of the 20th century, something changed. For the first time, the moon was not just something to observe. It was somewhere to go. The Soviet Union got there first, with machines. In 1959, a probe called Luna 1 flew past the moon, the first human-made object to reach it. Months later, Luna 2 crashed into the surface on purpose, becoming the first object from Earth to touch another world. Luna 3 swung around the far side and sent back photographs of terrain no human being had ever seen. The images showed a surface dramatically different from the near side, heavily cratered, with almost none of the dark plains visible from Earth. In 1966, Luna 9 settled gently onto the surface and sent back pictures. This mattered more than it might sound. There had been a genuine scientific concern that the moon's surface might be covered in dust deep enough to swallow a lander whole. The concern had been taken seriously enough that NASA had consulted on it before committing to send people. Luna 9 proved the surface was solid. A spacecraft could sit on it without sinking. Meanwhile, the United States was making a commitment that still seems difficult to believe. In 1961, President Kennedy told Congress that America would land a man on the moon and return him safely before the decade was out. At the time the commitment was made, the United States had a total of 15 minutes of human spaceflight experience. 15 minutes. The gap between what had been done and what was being promised was staggering. The program suffered early. A fire during a ground test killed 3 astronauts, Gus Grissom, Ed White, and Roger Chaffee. The program halted for 20 months while the spacecraft was redesigned. When it resumed, it moved fast. In December of 1968, Apollo 8 carried 3 astronauts to the moon, not to land, just to orbit. Frank Borman, James Lovell, and William Anders became the first human beings to leave Earth's gravitational pull, travel to another world, and see its far side with their own eyes. On Christmas Eve, they broadcast live from lunar orbit to roughly 1 billion people on Earth. But the moment that endures from Apollo 8 is a photograph. William Anders looked out the window and saw the Earth rising above the gray, barren lunar horizon. He took a picture. Earth appeared as a small, brilliant blue and white sphere, fragile and alone against the blackness. The image became one of the most reproduced photographs in history. Many historians credit it with helping to launch the modern environmental movement. The astronauts had gone to explore the moon. What they discovered was the Earth. 9 months later, 2 men would not just orbit the moon, they would land on it. On July 20th, 1969, the lunar module Eagle separated from the command module Columbia and began its descent toward the Sea of Tranquility. Neil Armstrong was at the controls. Buzz Aldrin was beside him, reading instruments. As they dropped below 1,000 feet, Armstrong could see through his window that the computer was guiding them toward a field of boulders. He took manual control. He flew the craft forward, searching for clear ground while the fuel gauge dropped. Mission controllers in Houston watched the numbers and said nothing. There were seconds of fuel remaining when the shadow of a landing leg appeared on the dust below. Armstrong's voice came through the static, calm and precise. "Houston, Tranquility Base here. The Eagle has landed." The name was his own choice. Tranquility Base. He had landed in the Sea of Tranquility. It was not an ocean. It was ancient lava, 3.5 billion years old, covered in a fine layer of dust that had never been touched by anything alive. Hours later, Armstrong climbed down the ladder of the lunar module and became the first human being to set foot on the surface of another world. As he stepped off the bottom rung, he spoke. "That is one small step for a man, one giant leap for mankind." He insisted afterward that he said the word, that the sentence was meant to contrast one person's small step with humanity's larger achievement. The audio is unclear. Computer analysis decades later suggested the word may have been present but masked by static. It remains unresolved, a small mystery attached to the most watched moment in human history. Aldrin followed him down. He stepped onto the surface, looked around at the flat gray plain stretching to the sharp horizon under a black sky, and found 2 words for what he saw: magnificent desolation. The sky was black, not dark blue, not deep purple, black. The moon has no atmosphere to scatter light, so even in full daylight, the sky above the surface is the black of space. The sun blazed with unfiltered intensity against that darkness. An Earth hung overhead, 4 times the apparent size of the moon as seen from Earth, visibly rotating, showing swirls of cloud that shifted over hours. It neither rose nor set. It stayed fixed in the sky, because the moon is tidally locked and always shows the same face to Earth. The silence was total. No wind, no ambient sound from the landscape. Inside the suit, an astronaut could hear the hum of life support equipment and his own breathing. Outside the suit, there was nothing. Sound cannot travel where there is no air. The footfalls that left those famous prints made no noise that reached the astronaut's ears from outside. The surface was fine-grained and cohesive. It compressed cleanly under boot pressure, but did not flow or collapse. The boot print held its shape perfectly, every ridge and groove preserved in the dust. It would hold that shape for a very long time. There was nothing on the moon to disturb it. The dust was everywhere. It clung to the suits, the gloves, the visors, the equipment. The regolith was electrostatically charged and unimaginably fine. Billions of years of meteorite impacts grinding rock into powder, with no wind or water to carry it away or round its edges. It stuck to everything it touched. It worked its way into the joints of equipment. It scratched visors. It cut the seals on specially designed sample containers, allowing air to contaminate the rocks inside during the trip home. And then Armstrong and Aldrin climbed back into the lunar module, sealed the hatch, and removed their helmets. A new scent filled the cabin. Armstrong later described it precisely. He and Aldrin were aware of a new scent in the air that clearly came from all the lunar material that had accumulated on their suits. He called it the scent of wet ashes. Harrison Schmitt, the geologist who walked on the moon during Apollo 17 3 years later, put it differently. He said everyone's instant impression of the smell was that of spent gunpowder. The moon has a smell. This ancient, airless, silent world, 4.5 billion years old, with no atmosphere, no life, no chemistry that anyone expected to be able to detect with a human nose, smells like something burning. The cause is the dust itself. Lunar regolith is chemically reactive. Its oxygen bonds were broken billions of years ago by solar radiation, and in the vacuum of the surface, they stayed broken. When the dust met the moist air inside the lunar module for the first time in billions of years, those bonds reacted instantly. The result was an odor every crew noticed: gunpowder, charcoal, wet ashes, a recently fired carbine. Schmidt's nasal passages swelled so badly he could barely breathe. It was the first case of extraterrestrial hay fever. Armstrong and Aldrin slept that night in their helmets and gloves, partly to avoid breathing the dust floating in the cramped cabin. The samples that made it back to Earth have no detectable smell. By the time they arrived, the reactive bonds had been satisfied. The dust had already reacted with the small amount of air in the sealed containers. The smell exists only in those first hours after a moonwalk, in the cabin of a lunar module, with the dust still fresh. It is a smell that has been experienced by only 12 people in the history of humanity. While Armstrong and Aldrin stood on the surface, a third man orbited above them. Michael Collins circled the moon alone in the command module Columbia. Every 2 hours, his orbit carried him behind the moon, out of radio contact with both his crewmates and with Earth. For 48 minutes of each orbit, he was more separated from other human beings than anyone had ever been. Every living person in existence was on the other side of the moon. Collins wrote about this solitude later, not as loneliness, but as a profound and singular quiet. 12 people stood on the moon across 6 missions. The last of them left in December of 1972. One mission was aborted, and its crew returned safely. In 3 years, those 12 people collected 382 kilograms of rock and soil. The later missions carried a small electric car, the lunar roving vehicle that let astronauts drive across the surface. The last person to stand on the moon was Eugene Cernan, commander of Apollo 17. Before he climbed the ladder for the final time, he spoke. We leave as we came, and God willing, as we shall return, with peace and hope for all mankind. That was December of 1972. More than 50 years have passed. No one has been back. For 18 years after the last Apollo mission, no nation sent anything to the moon at all. The attention of space agencies shifted to space stations, the space shuttle, and missions to other planets. The moon sat in its silence, as it had always sat, keeping everything that had been left there exactly as it was. When spacecraft returned, they carried instruments instead of people, and what they found changed the moon's story. Clementine, a small NASA probe in 1994, found radar hints of something in the permanently shadowed craters near the moon's poles. Lunar Prospector 4 years later detected hydrogen concentrations at both poles, a strong indicator of water ice. In 2009, NASA deliberately crashed a rocket stage into a crater near the South Pole and flew a second probe through the debris cloud. The instruments detected water. Not much, but it was there. The craters that hold this ice are among the strangest places in the solar system. Their floors have not received direct sunlight in billions of years. The temperatures there are the coldest ever measured by a spacecraft anywhere, colder than the surface of Pluto. In that permanent darkness, water molecules delivered by ancient comet impacts have remained frozen for eons, sitting in shadow, waiting for nothing in particular. In 2020, a telescope mounted inside a modified passenger jet, an observatory called Theia, flying above most of Earth's atmosphere, confirmed water molecules on sunlit portions of the lunar surface, not just in the shadowed craters, on the surface, in the light. The quantities are tiny, roughly the equivalent of a small bottle of water spread through a cubic meter of soil. But the moon, once thought to be completely dry, has water. But the moon is not waiting for anyone. It has never waited for anyone. It has simply been there, as it has been for 4.5 billion years, keeping everything. The dust that smelled like gunpowder when it met air for the first time in billions of years has now settled back into airless silence. The reactive bonds that caused the smell have been spent. The scent is gone, chemically pacified, and will not return until someone opens a hatch on the surface and lets moist air touch the ancient powder again. The boot prints in the Sea of Tranquility are exactly as sharp as they were the moment they were made. Every ridge from the sole of a 1969 spacesuit boot is preserved in the regolith. There is no wind to fill them, no rain to soften their edges, no footsteps to cross them. They will remain that way for millions of years, long after every building, every road, every monument built on Earth has been eroded or buried or forgotten. The laser reflectors still work. A beam of light fired from an observatory on Earth still bounces off a small panel sitting in the gray dust, returning a signal that tells us the moon is 3.5 centimeters farther away than it was when the last person left its surface. In geological terms, this is nothing. In human terms, it has been more than 50 years. Cernan said they would return, God willing. For half a century, no one did. The moon sat in its silence, keeping everything, noticing nothing. And then, on the 1st of April, 2026, a rocket lifted off from the same launch pad in Florida. 4 astronauts, Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen, rode a new spacecraft called Orion into orbit and then fired its engine toward the moon. It is the first time human beings have left Earth's orbit since Cernan climbed that ladder in 1972. They are not landing, not this time. They will fly around the moon, passing closer to it than any human has been in more than 50 years, studying its craters and ancient lava flows from the windows of their spacecraft. The night of this upload, on April 5th, 2026, means tomorrow they will see the far side with their own eyes, terrain that only a handful of Apollo crews ever witnessed directly. And then they will return home. But the Artemis program is not finished. Future missions plan to set boots on the surface again, near the South Pole, where water ice sits in craters that have not seen sunlight in billions of years. If that happens, new dust will be disturbed. New regolith will cling to new suits. And when the helmets come off inside a new cabin, the ancient powder will meet moist air again, for the first time since the last Apollo crew sealed their hatch. The smell of gunpowder will return. It has been waiting there the whole time. The craters from 4 billion years ago are still there. The lava plains that Riccioli named after seas are still there. The footprints are still there. The flag that fell over when Eagle lifted off is still lying in the dust. The moon keeps everything. And for the first time in half a century, someone is coming back to see it.